Hello everyone, welcome to this video tutorial on user-defined functions in MATLAB. These are the learning outcomes of this video. After this video, you will be able to understand what are the input and output arguments for user-defined functions. Then you will be able to create a user-defined function in MATLAB and you can call the user-defined function in MATLAB programs. So what is the function? The function can be expressed in the form of y is equal to f of x, where f of x is usually a mathematical expression in terms of x. For example, a function of line can be defined as y is equal to mx plus c, where mx plus c is usually a mathematical expression in terms of x. Now, the value of x is an input variable, or we can say is an input. It is substituted in expression to get the value of y. Thus, y is an output argument here and x is an input argument. Now, why we need a user-defined functions in MATLAB? When functions need to be evaluated many times for a different value of arguments, then it is convenient to create a user-defined function for that expression. So what is a user-defined function? A user-defined function in a MATLAB is a MATLAB program that is created by a user, saved as a function file, and then used like a built-in functions in the MATLAB programs. So structure is like that. We have to provide input arguments that those are read by function file, processed by function file, and we'll get some output arguments. So for example, let's do an example, solve an example, or create a function file for this example. Okay, so the example is that we have to calculate a maximum height that ball reaches when thrown upward with a certain velocity v0. The expression, mathematical expression for this example is given by h max, that is a function of v0 is equal to v square by 2z, or v0 square by 2z. Okay, so to create a function file in MATLAB, you have to open a function file. Okay, so procedure is like click on home tab, then click on new drop down menu and click on function. So after that, this function file will be opened. So this is a general structure, a blank copy of a function file. Then we have to edit this function file according to our need. So this is the general format of function. So it starts with a function definition line, which this line starts with a function keyword to define the function, which is followed by output arguments that are required as output of this function. Then we have a name of the function in bracket input arguments. After that, we have a function heading where we write what this function is for, and then we have function information like input argument information and output argument details. Then we have function body. That's the general format of the function. Now let's go to the MATLAB to create a function. Okay, so as I have said, you click on this home button, then new, and then go to the function to open the untitled blank copy of the function file. Okay, now this is your function keyword. Then we have some output arguments. Then we have name of the function. So here we will change the name of the function as max height. So here you have to use the rules to define how we define the variable. Same rules can be used to define the function names. Okay, then in input arguments we have v0. So I will say it is an initial, v initial. Okay, then in this heading we will write this function calculates the maximum height of the ball when thrown wn upward with initial velocity v underscore initial. Then we'll write information about input arguments. Then again tab v initial is nothing but the initial velocity of the ball as in length per unit time, gth per unit time. Velocity is meter per second, so length per unit time. Okay, so after that that's it for input arguments, and we'll get output arguments. Then what we'll get a max height. The maximum height, we'll copy it from here of the ball and of the ball. Control C and Control V. Delete this thing. Okay, so that's it. This is the information that user needs when he will be using or she will be using this function. Okay, so after that we have to write this expression. So output argument, we have only one output argument. We'll define it here directly. Okay, so we get max underscore HEIGST. Okay, so that's the output argument. So we'll define an expression for this maximum height using this maximum height is equal to, so what was our expression? Our expression is v initial square. So we are using this as an input argument. Okay, square. Now we'll complete with this bracket and then the value of g divided by g. So g here is nothing but 9.81 meter per second square gravitational acceleration. So 9.81 value is, we have to write a information. Okay, so we need not to use this second expression of output argument 2. That's it. So it's finished. We have function maximum height. Maximum height is the name of the function and this is the input argument required. Then we have this information, then we'll go to this expression. That's it. 2g, that was 2 star g. Let me, yes, v square 2 star g. Okay, so that's it. You have defined the variable. Now the next step is saving the variable. Now while saving this variable, you must save this variable with the name of the variable .m, like this. It will automatically detect the name. You just have to click on save, enter. That's it. So this name will appear here, max underscore height .m. Now how to use this function? How to call this function? To call this function, just write max underscore height. Now you can see here there is a, we'll close it. Now this is the command window. Now if you want to see how does this function work, just press F1. You'll get information, max height, help. Now in help you will be getting this information. Okay, so this function calculates the maximum height of the ball when thrown upward with the initial velocity v initial. Okay, now close this thing. Now we have to just provide the input argument. Let's say initial velocity is 10 meter per second, and that's it. So you get the value of 490.5. So this is how you can define a user defined function, and you can call it in a command window. Now if you have to use it in a script file, then you can open the script file. Then let's I'll say how to call user defined function in script. So this is the way. Now you can define a variable. So let's say max. So height, I will just use height, HEIGST, height of the ball is equal to max height. This is the function we required. And for, let's say, now we have initial velocity v initial, let's say 50. Okay, then you have to save this file if you have to run this thing, but you can run, and you can click on run in advance, and this can run this file. This will run this file without saving. Sorry. So this is the height of the function, height of the ball when it is thrown with the initial velocity of 50 meter per second. So that is something huge. Okay, so you can cross check it with this thing, 50 star or 50 square divided by 2 into 9.81. the value is same. So this is how you can define a user defined function in a MATLAB, and you can call it. Now we'll go to the this thing, slides. So this is the general format. Now there is another thing you should know about the functions. There is another way to define a user defined functions that we in MATLAB called as an anonymous function. So anonymous function can be defined in any part of MATLAB. That is, in command window you can define the anonymous function, in script files, or inside regular user defined functions. So what are anonymous functions? It is a simple one line user defined function. So you need not to save it, you can directly use it. So this is the syntax. So name argument list. So here you have to provide the list, and you have to write the expression, and you can directly use that function. Okay, so these are some examples. If you have to calculate the square of x, you can directly write square, that is the name of that variable, I will say, which is input argument here required is x only, and x square is the expression. For the circle, sorry, this is not circle, I have changed the expression while typing. So this is an expression, I have defined it here for this variable name circle, I will say. So generally this is not this expression does not related to circle. Earlier I was doing something else, and at the time while typing I changed the expressions to show that how multiple input arguments can be used. So let's go to the MATLAB and define an anonymous function. Okay, so we'll define it here in the command window itself. Let's say we'll define first a square one, SQURE square anonymous function. So it's, you have to start with @ then you have to write the input argument. So input argument is x, and the expression is x square. Okay, so that's it. Now you have created the function. Then you how to use this function, you just have to copy this name and define the value. Square of 2 I want, and redo unrecognized function or variable x. Okay, let me see what's the problem. Yeah, so while defining I have done some error. Let's define it again. In input argument I have used lowercase x, and while writing the expression I have used the uppercase x. That was the problem. Now we can generally do it without an error. So that's it. So square underscore af, we have defined an anonymous function to calculate the square of 2, and that stands. Okay, so you can see here both things. Square af at the rate x square, so it is used to calculate the square of x. Then you can see. Now we'll calculate the expression given here. Okay, so we'll do this thing. Sorry, at the rate xy exp x square. We'll use two input arguments. Let's say an anonymous function 2 is equal to at the rate. It is a function of x comma y. Okay, both are lowercase letters. Then exp what is the exp x square divided by, the expression is sqrt y square plus 5 square sqrt square root y square plus 5. Sorry, that's it. So this is the one line anonymous function we have defined to calculate this whole expression. Now we use this thing. Now to call this af underscore 2, and we have to give two values. Let's say x value is 2 and y value is 5, and that's it. So you'll get the again I did a mistake. So MATLAB is case sensitive. This should be lowercase letter, then this changes to this, and then I can just recall the previous inputs using up arrow enter, and we got the value. Okay, so this is how you can create a user defined function and anonymous functions in MATLAB. Okay, now let's move to the next slide. Okay, so this is the last part of this video, the function of functions. This is the case when function a is one of the input argument for a function b. So this takes this form. So we will define a new function. There are some output arguments. This is the function name, and function b, or this is the function b actually, and function a will be an input argument, and there are some other input arguments as well. Now let's move to the MATLAB. We'll create one function first. Let's define a function. Let's say it will be a polynomial expression. We get the output, and this will be function let's say a, and we have input argument x only. This is nothing but this is a function to calculate the polynomial. Okay, now we have input argument x. This is input value for which the output output of polynomial is calculated. Then we have output argument. Out, or we'll define it as y. Okay, here it will be a y. So y is nothing but output of polynomial expression. Now the expression is like that: x, the x is caps here, dot cube plus 5 star dot star x dot square plus, sorry, this I will make minus, then 7x 7 dot star x plus 15. Okay, so that's the expression. We have output argument as a y, and this will become our expression 1. We are not needing these things, so the y is nothing but, here we'll make this as a caps y. So this is the polynomial expression x cube. Make it clear. So x cube x square minus x 7x plus 15. Okay, that's it. So we'll save it using a function a. Now that's the function a. Now we have to create another function. Let's create another function. This will be our function b. Okay, and then we'll call this function here. Now here we'll only write this as a fun. Then there will be a range of x initial and x final. We'll call all this here. Okay, so this is a demo of function of function. Okay, that's it. Then we have detailed explanation here of input arguments. Function, this will be to evaluate it. Okay, then we have initial value x initial, we'll directly copy this thing, starting value of x for a range, then we have x final, and value of x for a range. Okay, then we have output arguments. What output arguments we have? output let's say y values of expression in function output values of expression in a function. Okay, now first what we will do, we will define a y range, x range is equal to linearly spaced lin space. Okay, now what we want x1, that is x initial comma x final. Okay, and how many values we want, let's say 100 values. Okay, then what we are going to do, we are going to call this function output is equal to function of. Now how many values, input values for this function are required? Only one single value, so will this give this function as a range. Okay, that's it. We have defined a function of a function as well. Now what we'll do, we'll delete this thing. We just have to change the output arguments, so output arguments will become output only. Okay, so we'll get the multiple values of x. Now we can also use a plot function. We'll do it later. Now we'll plot it here. We'll plot the value of x range comma output. So here we have output. Okay, output of underscore y we will do to differentiate from any previously saved variable. Okay, so that's the thing. We have plot and we just have to save this thing. Okay, with the same function b. Now what we will do, we will call a function b, and we have to give this function as an input variable, so that can be given as a handle. So you have to use @ and then you have to type function a. I'll do this thing like this, function a, then the x initial value of x will be 0 and the final value of x will be, let's say, 10. Okay, and we'll close it, and that's so output value from range. Something is different. Error, unrecognized function or variable fun. So what is the problem? Yes, this is capital F and this is small f, so we will save this and once again we'll run this thing. Now this should run now. You can see here we got a plot as well, we got the output values of x range as well or a y range as well. Okay, so what we are getting, a y range, sorry, not x range. So we'll see what we are getting. Yes, those are the values. Okay, and the plot again. So this is how a function works. We have defined a function, or we have called a function inside a function using this function procedure, I'll say. So okay, let's go to the slides. That's it for this video. We'll meet again. Thank you for watching this video. Please like, share and subscribe to the channel. Thank you.